GCSE questions on bounds. Question 1, this is from a past paper. A is 6.43 and B is 5.514. We've given the formula there. V is equal to the square root of A over B. By considering bounds, work out the value of V to a suitable degree of accuracy. You must shoot all of your workings. To do that, I think you've got to work it out for both the higher and the lower bound. So this is what I've done. For the higher bound of V, because that's your formula, 6.43, the highest it could possibly be is 6.435, and the lowest is 5.5135. So that equals that. For the lower bound, you want the lowest possible one on top, and the bottom you want the highest one, so it could come out to that. And I think 2 decimal places is a suitable degree of accuracy, as this was the degree of accuracy given in the question. And the final answer, so it'd be 1.08. And if you want, after that, you can write 2dp for 2 decimal places. Question 2. A ball is thrown vertically upwards at a speed v meters per second. There's the formula. Write down the lower bound of g. To find the lowest bound of g, what you need to do is have the lowest possible value on top. Lowest value of g, so beg my pardon. Lowest possible value of g would be 9.75, because that would round up to that. And calculate the upper bound of h, so you want to make h as big as possible. To do that, v squared must be as large as possible, and 2g must be as small as possible. So you round up the 24.4 to 24.45, and it's squared like it is at the top. And the bottom one, you need it to be the lowest it can be, which is 9.75, and that equals 30.6565. And it says give it to 3 significant figures, so that's 30.7, because the 5 rounds up to 6. Question 3. A field is the shape of a rectangle. The width of the field is 28 metres to the nearest metre. Work out the upper bound of the field. 28.5 is as high as it can possibly be. Work out the upper bound for the perimeter. The length is 145 to the nearest 5 metres, so the biggest that can be is 147.5. So work out the perimeter by adding up all the highest possible bounds. So there's 2 lots of lengths and 2 lots of widths here. So 352, sorry. Question 4. It's about driving. Work out the upper bound for the petrol consumption. To work out the upper bound, the highest one must be the highest it can be, and the bottom one must be the lowest it can possibly be. So it says she drove for 238 miles, correct to the nearest mile. That means she could have done 238.5, possibly, and to round 27.3 down to the lowest it can be is 27.25. So 8.75229, 2 decimal places, so 8.75 is your final answer. Question 5. Work out the total surface area of the cube. Straight surface area question. One side is 5 by 5, which is 25, and on a cube, like a dice, there's 6 of them, so 6 25s is 150. The volume of a cube is 125 centimetres cubed, because it's 5 times 5 times 5 for the one at the top. Change that into millimetres cubed. What you need to be aware of is that 1 centimetre cubed is the same as 1,000 millimetres cubed, because you imagine 1 centimetre is 10 millimetres, so to get 1 by 1 by 1 is 1 centimetre cubed, so 10 by 10 by 10 millimetres is 1,000 millimetres cubed, so you need to multiply it by 1,000, so it's 125,000 millimetres cubed. The weight of the cube is 87 grams. What's the minimum it could be? 86.5. And what's the maximum? 87.5. Next one, question 6. The length of a line is 63 centimetres to the nearest centimetre. Least possible length, 62.5. Greatest, 63.5, or 0.5. Question 7. Voltage of an electric circuit is given by the formula V equals IR. I is the current, R is the resistance. Calculate the lowest bound of I. To do that, first of all, you've got to make I the subject to the formula. So I've said that here. So I equals V over R. If you want I to be the lowest, you've got to lowest it can be. V needs to be the lowest, and R needs to be quite high. So the lowest V could possibly be is 217.5 because it's to three significant figures, and the highest this could be is 12.65 with three. So work that out and you get 17.19, and that's your work on bounds.